Hello, and thank you for coming. I wasn't sure if anybody was going to come because I thought they might be a bit bored. I thought Laura might come, so I'm quite happy you're here, but everybody else might not come along. So thank you very much for the invitation to speak here. I really appreciate the opportunity to talk about the science projects that Historic Environment Scotland, or I'm going to call us HES from now on, so just so you know what you mean, the ones that we're involved in. And for those of you who don't know me, as David mentioned, I'm the Archaeological Science Manager. It's a very new role in HES, appointed in July 2017. So we have a very well-established conservation science department, which I'm sure a lot of you have come across, but this is really the first post to concentrate strategically on the coordination, accessibility and promotion of archaeological science in Scotland. So what I plan to do this evening is take you on a little bit of a whirlwind tour of some of the heritage science projects which HES have developed, the ones we've enabled, whether that be through funding, or those that are being undertaken by members of staff. This means that I'll be presenting entirely the work of other people, so I can take no credit whatsoever for this. A lot of amazing people have shared a lot of information with me, for which I'm very grateful. For the purposes here, I'm using the term archaeology in its widest possible sense. That is, it's the study of the human past through the material remains. And so what I wanted to do was include everything from excavated remains to buildings, and I've even got a painting in here as well. So I've tried to group the projects a bit thematically, moving from radiocarbon dating into ADNA, looking at landscape, then some conservation science, and digital science as well. I want to show how each project is stimulating science and making the most out of recent innovation in order to provide a much more nuanced understanding of our past. At the end, I want to conclude by looking to the future that the direction archaeological science might take. And I see Sophie up there, and you're in there, you're the future. So before I launch into the project, hopefully this works, yay. I wanted to spend just a very quick 5 minutes looking at the strategic and research frameworks that underpin all of the archaeological work that we, and that's the sector, not just HES, are undertaking. If it wasn't for these, I wouldn't have a job, so I'm quite grateful. But also it's a way that we are looking at focusing and prioritising research in archaeological science. So in Scotland, we're the great advantage to have both the archaeological strategy as well as a national and emerging regional research frameworks to give direction. So I'm just going to spend a little bit of time, very short. So start by mentioning Scotland's archaeology strategy. It should be noted this is not an HES strategy, this is a strategy for the whole of the archaeology sector, and it's intended to be a guide for how archaeology can be undertaken. Its creation was led by HES, but actually with guidance from the Scottish Strategic Archaeology Committee. Now that had representation from archaeological science, but also from the Society of Antiquaries, the Chartered Institute for Archaeologists, commercial sector, and many, many more. So the strategy is intended to be representative of all those who want to be involved in who want to be involved in archaeology, in Scottish archaeology, from the local communities right the way through to the academics. So the vision is a Scotland where archaeology is for everyone. We want a Scotland where the study of the past can offer opportunities for us both now and in the future to discover, care for, protect and enjoy our rich and diverse heritage. I don't think anybody can argue with that. One of the other things we want to do is to look at telling Scotland's stories in its global context. It has 5 strategic aims, which are outlined here. Delivering archaeology. We want to broaden and deepen the impact and public benefit of archaeology, both within Scotland and beyond. We want to enhance our understanding, increase knowledge and understanding of our past, and also interpretation. Caring and protecting, because we want to ensure that the management of the material evidence for the past, that it's cared for by society and that it's managed sustainably for present and future generations. We also want to encourage greater engagement, to enable and encourage engagement with our past through creative and collaborative working, active involvement, learning for all ages, but also enhance archaeological presentation. So all of the projects, I've missed out the last one there because I'm about to go on to it, because all the projects I'm going to present have aspects of all aims 1 to 4, but it's actually aim 5, innovation and skills, which I think is a bit more applicable to what I'm talking about today. So within the delivery plan, we have 3 very specific objectives relating to archaeological science. So the first is the support and promotion of science-themed workshops. These are to increase awareness and knowledge of archaeological science. So these workshops are usually externally organised. The most recent one that we had was the Archaeological Chronologies, which was led by the Scottish University's Environmental Research Centre, or SUARC. And they looked at different dating methods, ranging from radiocarbon dating to OSL. They looked at dendrochronology and even lead 210. At the moment, we're looking for what our next archaeological science workshop could be, so I'm always open to ideas. If anybody has any, I'm more than willing to hear them. With regards to prioritisation of science research projects, science research ideas to students, one of the things that we're doing is to promote and put online all of our unpublished projects, and so there is a list that's starting to appear up online. And what we want to do is to encourage people to come talk to us about some of these. If they have some quite innovative ideas about how they want to bring these to publication, then we're more than willing to listen to people. As for the mechanisms for science advice, the creation of the Archaeological Science Manager is part of this, but I'm not here to provide the science advice. I'm actually starting to look at the best ways of how we could provide a Scotland-wide advice, because obviously Historic England have all their science advisors, and it's looking at whether and what we need in Scotland that would suit our purposes. I can't talk to the antics and not talk about Scarf. So I think that the other important piece of the science puzzle to consider is the science panel from the Scottish Archaeological Research Framework. What it does is it acknowledges that science is fundamental to our understanding of the life stories of people who we have met, who interact and lived in Scotland throughout history and prehistory. It states that Scotland has the potential to be a world leader in the development and application of archaeological science, with skilled people and technology distributed across the country. And I'm hopeful that some of the projects that I'm going to present will show you how we're doing this. There were quite a number of recommendations that came out of this panel, that we focus on high quality and high impact research. We look at utilising large scale and multidisciplinary projects to stimulate research, looking at demography, movement and contact of people, societal resistance, how people coped with climatic change. They were also talking about the integration of archaeological science into projects as a matter of standard and a matter of routine, with results stored, disseminated and made accessible. I think this is linked with effective and coordinated dissemination of the results, and I look at Peter because I think that Canmore has a huge place to play in that, so I'm looking forward to seeing what we can do. The other thing to look at was how we promote knowledge exchange and transfer. So the knowledge, data and skills need to be routinely transferred and embedded across the whole of the archaeology sector. We want to enable archaeological science community to work together so we can establish routes of communication and we can improve infrastructure in this area. One of the ways to do this is potentially a network for specialists was suggested, that they could provide advice, raise awareness of current work, create series of interdisciplinary working groups, so that we can discuss and articulate archaeological science issues. It's also hoped from the panel report that these would be looking at long-term sustainability of Scotland's archaeological science facilities and build a legacy for the next generation of researchers. They need a solid foundation, they need to look at how these are funded, access to resources, and also creating recognised career paths, so that if you are in school and you want to be a scientist, why not be an archaeological scientist? So, take you through. One of the biggest advances in scientific archaeology was the radiocarbon revolution. Pioneered by Willard Libby in the 1940s, radiocarbon dating was an innovation which had roots in nuclear physics. Now, I'm sure you all know what radiocarbon is and how it's applied, but I wanted to put up a little bit of a refresher slide. I love this at the bottom here. So I think this is a brilliant diagram to illustrate how radiocarbon gets into us and animals. So the majority of radiocarbon is formed in the upper atmosphere when it's bombarded with cosmic rays. Lots of nuclear reactions go on. Neutrons interact with the nitrogen-14 and carbon-14. It's taken in by plants in the form of carbon dioxide and is transferred to humans and animals when they eat the plants. So When something dies, it stops taking in radiocarbon and it starts to decay at a known rate, so 5,370 years, and that's the half-life. Now, as fantastic as this technique is for understanding the chronology of our past, it does come with its own issues, and one of them I wanted to mention, because it relates to the first project, is the Hallstatt Plateau. So this is a period of 400 years in the early Iron Age where the radiocarbon curve is actually fairly flat. It makes it really difficult to get precise dates. This doesn't just have impacts on understanding the date of sites, but also how people are living in and moving around the landscape at this time. So the first project I wanted to highlight, which is focusing on this 800 to 400 BC time period, is Living on Water, which has been undertaken by researchers at Zurich. What they're looking at is the development of crannog dwellings, so these artificial island dwellings, which are located around Loch Tay and occupied in the early Iron Age period. They're using a technique called wiggle match dating to try and narrow down the chronology of settlement at the site. In very, very simple terms, wiggle match dating uses a combination of high precision radiocarbon dates and dendrochronology, so tree ring dating, to map changes in radiocarbon content over a known period of time. This can then be matched to wiggles in the radiocarbon curve and giving us very precise dates. And in some cases for this project, we've got 15-year date ranges for some of these structures, which is quite fantastic. The aim is to use the results of this chronology to develop a social history of crannog dwelling at this site, answering questions about density of settlement. Is it a single or a small group moving around the loch, or is it like a massive landscape of huge numbers of people living there? Were they occupied at the same time, different times? The project is just about to enter its final year, but what they have suggested is that Oakbank Crannog, so if I try and find it up there, so that's that one there. So Oakbank Crannog, what we have indicated from timber that they've done is they've got a felling date of between 500 and 475 calibrated BC. And what they can also find is that we've got more timbers that are showing us date ranges between 405 and 385 calibrated BC. So in this period of where we're finding it difficult to pin down radiocarbon dates, they've got these really short timescales. What it is important is that the later date range for Oakbank Crannog is it's contemporary with periods of construction at Dalbay South Crannog and Milton Moornish. So there you go, Dalbay South and Milton Moornish. So what you can start to do is look at contemporaneous settlement in these areas. We await all the results from the further excavations that were undertaken in 2018 to see if this trend continues, but I think it's definitely watch this space. It's got very exciting things going on. See, Total War Wood tour, you're going to love it. All right, Scottish medieval castles and chapels. It's another project that's using radiocarbon in quite an innovative way. This is postdoctoral research, which has been undertaken by Dr. Mark Thacker at Stirling University, who is using a combination of analyses, very much a multidisciplinary approach, to improve our understanding of the context and chronology of medieval castle and chapel structures. So he's using palynological study, so plants and animal pollens, looking at what makes up the landscape. He's utilising information from archaeological excavation on the sites. He's undertaking historical research to gain an insight into the life cycle of structures, when and how they were traditionally believed to have been constructed, and the technology of construction, such as the mortar being used, the longevity of occupation, and using building recording to identify phases of construction and remodelling. And that also includes conservation works that we've done in the past. So he's taking it all into consideration. What I really like about this project is he's also using oral histories as an important piece of information and feeding that in as well. So for radiocarbon dating, he's actually taking small mortar samples and then looking at the fragments of wood charcoal which have become trapped within the mortar while it was being made. So we're talking really tiny pieces of charcoal. One of the problems he's encountering, however, is where oak has been used in the creation, or as the fuel source for the creation of the mortar. You might have heard of something called the old wood effect. So oak can have a bit of a long life, so we don't usually like to use it for radiocarbon dating because it can give you potentially artificially early dates. In order to deal with this, he's only dating charcoal that is identified to species. he's trying to use shorter lived species, so trying to use non-oak where he can. And where the oak must be dated, he's using multiple samples in order to try and replicate results. This project has often and is now actually able to present some of the first independent and direct evidence for building construction rather than using architectural typologies or historical references or excavated evidence, which can often lead to an understanding of occupation rather than foundation. So before this project, there was often no consensus, and any interpretation on dating is quite speculative. And what he's asked me to do is to include Castle Camas on Skye as a possible example. So that's it down here. So it's located on a steep side promontory in the southeast of Skye, and what the site does is talk about a number of problems that we have. So oral histories report it was the location of the Clan MacLeod stronghold, in which the clan chief died in 1402. There doesn't appear in contemporary documentation until the 15th century, well, much later in the 15th century, and there's a watercolour painting from the 19th century which depicts the castle as an upstanding monument and multi-storey. So the current limited survival of the structure, as you can see, has meant that the earliest remains have been classified as, I think he said, 13th to 16th century, which doesn't really help pin you down in history. So what he's been doing for his radiocarbon dates for this site is looking at all the earliest phases So when did he think this was constructed? And the new radiocarbon dates that he has at the moment are suggesting actually it was late 13th to early 14th century. And he's got a few more planned to try and get that even tighter. My final one, looking at different ways of using radiocarbon dates, is tracing the lines. So it's postdoctoral research by Dr. Mike Copper at Bradford University. And what he's trying to do is to create a database of grooved ware pottery. And I know he's working with Alison Sheridan quite closely on this at the NMS. He's looking at its context and associated artefacts. So what he's producing is a database of all Scottish grooved ware beyond Orkney. So he did Orkney before, and now he's trying to look at everywhere else. And he's actually just submitted to SCARF his database to be put online. So we're looking at making these things open and accessible. This project is using targeted radiocarbon dates to improve our understanding of the dating and evolution of this pottery style, and concentrating on the dating of the organic residues. So that's like the food that people ate that's left over in the inside of the pots the last time the pot was used. He's using these so that you can date use rather than deposition. He brought up with me when we were discussing this the site of Hill End, where the pot residue dates that were acquired actually show the vessels to be several hundred years younger than the previous date that came from a charred piece of organic material that was in the same context. And it was basically that charred material was redeposited in there, and actually what the pot's doing is telling us more about the activity. So at the moment he's doing Bayesian analysis of the dates to try and tie down. It's a way of looking at a statistical model where you can input information you know about stratigraphy and you can tie down these dates even further. And what he's trying to do is to assess whether the appearance of grooved ware was accompanied by changes in the methods of manufacture, because ethnographic research suggests that technology often correlates more closely with social identity than pot forms and the decorative motifs. So so he wishes he could add more detail right now, but I realised I probably should have asked for this lecture to be in April, after the end of the financial year, when everybody gives me the reports. So most of this is going to be watch this spaced until the results come out. And he does say it will be published in due course. Now, another area that we're looking at is ancient DNA. It's absolutely exploded in the last few years. So high-resolution sequencing of ancient DNA is actually exceptionally difficult, with specialists in this field having to deal with a number of different problems, from the recovery of material that's suitable from sequencing through to determining the level of contamination of a sample, whether that be from modern or from microbes, and often the samples are exceptionally degraded and fragmented because your DNA starts to break down as soon as something dies. And to give you an example of contamination, I actually did some ADNA stuff quite a while ago now, and they had to sequence all of the excavator's DNA first, so we had to give out hair. So they could make sure that when they were what they were sequencing was not one of us by accident, that it was actually the person that we were digging up. So the other thing I wanted to mention, because I'm going to talk about it, is when you're looking at soil or sedimentary DNA, we have an incomplete reference database, and that can cause problems on identifying what exactly that you're sequencing. Nevertheless, it has been growing in application, which I mentioned, following significant technological advances, and that includes the identification and the abilities to deal with contamination. So I wanted to spend a little time looking at various different projects that are making the most of this type of analysis. And I also wanted to talk a little bit about how we as a sector are attempting to be more strategic in how we're disseminating this type of information. And it's usually, I've put aDNA and isotopes because usually they're studied together, and I will be mentioning aDNA results. So I wanted to start with a couple of projects which were actually instigated by local communities, so local communities working with archaeologists, to use archaeological science to bring them face to face with the people of their past. If you remember back to the SCARF recommendations I was talking about, projects that are involving the wider community are supposed to be promoted, and they are opportunities for public engagement. And I think that both of these projects that I'm going to talk about here actually add significantly, are significant because they have a community lead, they included exhibitions, and they're therefore really great examples. So what I want to show is that you do not need to be a scientist yourself or have an academic background to stimulate academic and scientific academic research. I think that's really important. If you've got an idea, talk to the people in the know and they'll help you develop it. So the first one is, here is the Bridge of Tilt, where Guard Archaeology are working with the local groups in Bridge of Tilt, which is in Blair Athol in Perthshire. The project focuses on the remains of a long kist, which was uncovered in a village in 1986. It was dated to 340 to 615 AD. Now, there were a number of aims for this project, which included excavation in the surrounding area to get, of the kist to identify associated features. They wanted to undertake isotopic and aDNA study to gain an insight into what this man would have looked like, his diet and where he came from. And all of this information was then fed into facial reconstruction, you can see here, which I think is very handsome actually, I quite like him. And it was created by a forensic scientist, Hayley Fisher. We're still waiting on the aDNA results. I think if Alison was here, she might well have a bit of an insight into that, but unfortunately she is off with work at the moment. But what we do have are the isotopes, and what they're doing, and so that's them plotted up there, which I'm sure you're all super excited to see. So what they're saying is that the levels of the carbon isotope, so that's where the individual is getting his protein from, are all within the terrestrial range. So that means that he's eating animals that are on the land. However, what the Orsoilo Cesare, who is one of the kind of leaders in doing this at the moment, who's a PhD student, what she did was she plotted it up here against the against an Anglo-Saxon to give you a bit of a comparison. And what they were showing here is that their nitrogen range is slightly higher than the Anglo-Saxons. And she suggested that this could be because they are either eating freshwater fish or waterfowl or even pigs that would create this higher level of nitrogen. She also compared the results to the other Pictish sites in Scotland that she's been studying, both inland and coastal sites. And actually what it's showing is the same patterns as what you're getting here at Bridge of Tilt. It's especially interesting considering the lack of fish that seems to be eating at coastal sites. You would expect them to be using the resources in their backyard, but that doesn't seem to be the case. What they're currently doing is using another isotope, sulfur, to identify what might be causing the higher nitrogen value, because they'll be able to identify whether it's freshwater fish consumption. The results of this project were presented as part of the Picts and Pixels exhibition, which was on at the Perth Museum and Art Gallery, which allowed even more people to engage with the ancient folks of the area. And also it's feeding into much wider studies of Pictland in general. In a similar vein, we have Torbeck Sam. He looks a bit scarier, I think, than the other guy. But this is a partnership between Stirling Council and the Stirling Smith Museum. And again, it's about making the most out of the collections which are contained within our museums. So it was identified within Cooney Park, which lies immediately south of Stirling. There was antiquarian excavations of a series of prehistoric burials. The most impressive, if you can call it that, look at that, woo! The most impressive there is the Cooney Park cairn, which in the late 19th century was being quarried for sand and gravel, and when they discovered the kist. These were then stored in the newly opened Smith's Institute, which is now the Smith Museum and Art Gallery. There were further excavations on the site in the 1970s by Stirling Archaeological and Field Society. They reopened the disturbed kist, they discovered more remains there, and they also identified a second kist. So the main skull in there was subject to facial reconstruction by Emily McCulloch, and HES supported pathological analysis, radiocarbon dates, isotope analysis, and also the preparation of an aDNA sample. Now, again, still waiting on the aDNA results, but what we have managed to find out is that there were 3 individuals, 2 of them from the Bronze Age, and an interloper from the 13th or 14th century. Who was in there too. Now, it's not clear if this third individual was inserted into the prehistoric kist in antiquity, or later than that, or if it was a mix-up at the museum, but I think it's quite nice. I don't know, I'd quite like to be buried in a Bronze Age kist. That sounds kind of cool. So what the isotope analysis confirmed was that all these individuals were in the local area, and what's going to happen is when the DNA results come back, they're going to be fed in. Because these are digital reconstructions, it means that we can feed in all the additional information. We can get hair colour, eye colour, and skin tone right. Now, I wanted to move away, so you can see we've got quite a lot going on. So one of the things I wanted to talk about here was I wanted to mention the Ancient DNA database for Scotland. So I don't know if any of you were at the Rhine lectures way back in 2015. They were slightly different. Instead of a single speaker, what they did was they brought multiple speakers together who focused on British archaeology, its progress and its demands. And what became clear there was a lot of our ancient DNA analysis that's being undertaken on assemblages from Scotland. And there needed to be some kind of coordination of the results and a need for them to be made accessible. And this was something that's always been stuck out in my mind as a priority for the Archaeological Science Manager. So I had a quick discussion with Alison Sheridan at the National Museums of Scotland to see how we can do this. And Alison, being amazing, brought together in an exceptionally short period of time all the results of all the aDNA going on in Scotland that she knew about. It was really quite phenomenal. And what we're going to do with that in the first instance is to publish it in Discovery and Excavation in Scotland. And so we know we don't have absolutely everything. We'll need to contact a few of the kind of smaller museums. But what she has created, and if any of you are aDNA specialists or happen to have projects on the go, is she's given us this template to use, so for recording. So we're not asking for a lot of information, just asking for enough. And what we want to do eventually is to make this online. We want it to enable updates, and we want to ensure that open access to the results. So again, I look at Peter McKeague and hope that he can help. Taking notes, brilliant, fabulous. Because the CAMWare database is referenced in SCARF, and I really want to work with my colleagues with Peter in order to put this stuff up online, so you can go in and you can have a look and you can see what's going on. What I do want to say is one of the reasons for doing this is obviously open access, but it's also promoting ethical sampling, because we want to lessen the need for multiple samples from the same individuals. So if we have 10 projects wanting to do aDNA analysis or isotope analysis or radiocarbon dating, often you'll get a combination of all of these things together. So what we want to do is make that information out there so that you don't have to sample one individual 10 times. And actually, Alison and I were discussing this. We think, to our knowledge, that Scotland might be the only country in the world that has this. So that's pretty cool. Now, it's not just all about humans. My HES colleagues in Interpretation and Cultural Resources team have been working with researchers at the National Museums of Scotland, the Roslin Institute, the Royal Dick Vet at the University of Edinburgh, Dundee University and the School of Archaeology at the University of Oxford to use aDNA to inform a reconstruction of a Neolithic dog, the bones of which were found in Queen Chambered Cairn, which is in Orkney. So the project was initially initiated when the colleagues wanted to update the interpretation panel. I don't know if anybody's seen it, but it's pretty old-fashioned. And what they wanted to do was have a much better graphic, which you can see here, to understand what the mound looks like. So you can go into it and you can have a route around. As a bit of an aside to that, they wanted to update the depiction of the dog. So here is the current dog that is on the interpretation panel. And it's always an artist's interpretation, just so they could say, yeah, 24 dog skulls were found in here, but not really quite an accurate reflection of what's there. So to get a better idea of what the dog looked like, what they did was they laser scanned the skull, and they employed an expert in dog and also wolf. Now, Steve told me werewolf, but I don't know if he meant werewolf, but it might be werewolf. Her name is Amy Thornton. And so she was to recreate the skull because it's different from recreating the human skulls that you've seen before. The way that the muscles work in a dog's face, you know, what Steve referred to as the bitey muscles, are much more developed in a dog, surprisingly, and unsurprisingly, than a human. So what they wanted to do was to create this. Now, I'm not allowed, I've been embargoed to show you the final one, which is being launched at the International Science Festival in April. But as you can see here, which is the one that's getting its muscles put on, it looks completely different. I don't know, I think this might be a Welsh Terrier or a Fox Terrier or something like that, I have no idea. And here, what the ADNA analysis, or what we're hoping the AD analysis, as well as telling us about eye colour, fur, and that kind of information, what we're actually really interested in is the ears. So the ears. So in here, what floppy ears are indicative of domesticated dogs. So we're wondering whether or not the ancient DNA information can tell us whether or not this dog had floppy ears, and then we can then start to infer whether or not these dogs that were killed there were domesticated, which is not too shabby for a dog that's been in a museum for a very long time. All right, we're going to get a wee bit sciencey. Don't worry. I barely understand it, so I don't know how well this is going to go. So what I wanted to do was talk a little bit about an emerging type of ancient DNA analysis, which is sedimentary DNA. It's growing in its application. So what sedimentary DNA is the genetic material that is contained within a soil or a sediment. And what it does is it allows us to identify the presence of humans, plants, animals, and worms. Oh my goodness, so many worms. It goes by density, so worms, you get quite high. And what it does is it allows us to see the presence of these that we might not see from other evidence, so if you don't happen to have the remains from bone. So Blackloch and Merton, probably a site that you do know fairly well. It's an Iron Age village in Dumfries and Galloway, spectacularly preserved in the peat, and you can see the entranceway to one of the roundhouses there. Looks like 5th century BC, looks like you could have buried it yesterday. So a project that you might be less familiar with is one called Celtic Crannogs, and what they're doing is they're a group of scientists who are working very closely with the archaeologists at AOC. This is a multidisciplinary project in the highest possible sense of the word, which is studying lake settlements in Scotland and Ireland through coring and sediment analysis. What they're utilising is pollen, diatoms, insect analysis, geochemistry, lipid biomarker, DNA metabarcoding, and radiocarbon dating in order to get a much more nuanced understanding of these settlements, their chronology, their longevity, the intensity of use, and also environmental context. And you'll be glad to know I'm not going to talk about all of those things, otherwise you'll just fall asleep. So in Scotland, what they've been doing is taking cores at both Whiteloch and Merton, which is up here, and you can see here, that's the Crannog, and then Blackloch and Merton, which is down here. And what they do is they take a core from the central area of a lake or a loch, and then they take one from closer to where the settlement is. Because what they've identified is these catchment areas, so the information that is going to be contained within the core, are actually fairly small. The one in the middle of the loch, is what it's doing is telling you a bit more about general environmental conditions and systems within the loch, whereas the one closer to the settlement site is telling you a bit more about the human impact on the environment. So I wish I could tell you about all the phenomenal things that Celtic Crannogs are doing, But what I did want to do is pull out the ancient DNA and also fecal steroid analysis, because they're both often undertaken together, just to illustrate the potential of these techniques and what these stories are telling us. So I'm going to give you a wee bit of technical information. Hopefully it'll make sense to you. I tested it on my office today and they understood, so fingers crossed. So lipid biomarkers is something I'm going to talk about, and what they are is molecular compounds that have traceable biological origin. So they're often preserved within sedimentary environments and can act as molecular fossils. Within this broad group of lipids, steroids are a group of compounds produced by plants and fungi, which are incorporated into the fecal matter of higher vertebrates, i.e. us and bigger animals, through their diet. So by identifying the type and the different quantities of steroid compounds within an archaeological sample, we can start to detect fecal input. So the steroid composition of fecal matter is produced by different animals. It varies depending on food source, it varies depending on digestion processes, and also digestion bacteria. So therefore, if we understand and know the ratios of fecal steroids, we can discriminate between human, pigs, and herbivore fecal matter. So hopefully that makes sense. I wanted to start with Whitelock and Merton, because actually it worked really well here. It didn't work so well at Blacklock, but worked really well at Whitelock and Merton. Don't worry, don't need to understand this. I'm gonna explain all to you. You've just got left side, so this is the core they took. You've got dates, you've got the various analyses that have been undertaken here, and it's the ones at the end that we're most interested in. So the thing to know is that what we do is we sample and study steroids and sedimentary DNA separately. So you have two independent, so different samples, different cores, so you've got two independent studies. And so it means that there are separate indicators as a check for each other. So here, what you can see is that the steroids show a so you get a peak here and a peak here, very small peak there, but bigger peak there. And what that's suggesting, so no excavations ongoing here, this is all just from a single core. And what that's suggesting is that there are 2 periods of human activity on this site. And what is quite nice is that it actually corresponds to, we've got the trees here, and you can see there's a dip just when the humans are coming in, potentially clearing out your trees, and then it's going back up once the humans are going back down again. We're seeing here from these bile acids that we've actually got lots of cattle, lots of sheep in there. It gets a bit more mixed through time, and what they show is 2 phases, the 2 phases of occupation. So we have one 580 to 480 BC, which shows the clearest evidence, so that's your big peak here. And then we have a second phase, which is 480 to 270. So what is quite nice in this as well is that in the second phase of human impact, what we're getting in the pollen and the diatoms is an increase, we're getting increased pollen, diatoms, we're getting more wood, organic debris, and charcoal in sediment cores. So what's happening is when people are starting to live and work around the loch edges, what they're doing is they're changing the environment, and it's being picked up in the core. So it's the comparison between the two. So we can actually glean quite a bit of information from a single core. Hopefully that wasn't too technical for you. Right, don't panic at this one either. So Helen Mackay from the Newcastle University, what she's done is she's taken several columns through the deposits both within the roundhouse. So she's taken an inner one, looking at sediments here, and she's taken an outer one, looking at the sediments here, and she's taken another one 20 meters away, and that's what that is down here. That's just representative of the one 20 meters away. And so the main story with this one is actually the bile acids. And all you need to know is that DCA and LCA ratios are the ones that help us to identify the difference between cattle and sheep, or ruminants, and the humans. So that's what that is. That's all you have to worry about. Is that's how we tell the difference between these and then this. So what this slide is showing that there's actually 2 differences, both spatially and temporally. So spatially, the dung of the ruminants, so that's the sheep and the cow, are only found inside the structure. So, and even inside the structure, they're only found around about here in the center of the structure. which doesn't really make much sense, because if you are moving animals around outside your house, you would expect them to at least go to the toilet once. But for some reason, we're getting absolutely nothing on the outside, very little towards the outside edge of the house, and only in the centre around the central hearth. We've had quite an extended conversation about this, and we've discussed the potential of the burning of dung in order to if they're bringing dung in, putting it next to the hearth and burning it. But we actually have no indications of this from any other type of analysis from the macrofossil or the thin section analyses. So my personal favourite explanation for this, which I absolutely adore, is one that came from Finbar McCormick. That what we're seeing here is we're seeing young or weaker animals that are being carried into the house and then nursed back to health around the hearth area, and that's why you're only getting the information around the heat of the hearth. So I think that's quite a nice story. Something you certainly don't get by there being a presence of bone at the site. The other thing that we can look for in this is we can look at changes through time. So we've got early through to later, early through to later. And so what they're showing is there's evidence for human and horse at the beginning, in the earliest phases. More animals incoming, so you've got more animals incoming, but obviously centered around the middle rather than around the edge. It then continues in through the second phase. In phase 2, the inner column, obviously, lots and lots of animals in there, and then absolutely nothing, no fecal matter at all in these later phases. Whereas if you have a look at the outer edge of the house, you've got not very much going on, you've got some ruminants, you've got some pig, and then you've got this kind of larger concentration of human and your ruminants. So what this is starting to tell us, or we can start to identify, is changes in how the building's being used, and changes in the use of space, and also changes in activity that are occurring. So you can actually get a huge amount of information and some really nice stories that complements the archaeology. You need the archaeology to interpret it, but that's probably for another day, not for right now. So I want to move away from the microscopic, and I'm going to move on to something a little bigger. So we're going to be looking at landscapes. And what I want to talk about is how landscapes and how science can help us to reconstruct past landscapes and environment. So how we as archaeologists can use this information to better understand human activity. So I wanted to talk about this Wessex archaeology project, Paleolandscapes and Moyne Moor, where they're looking at an area which contains a rich archaeological landscape, which includes Kilmartin Glen, Donad, Riverad and Loch Crinan. For those of you who don't know the area, the Donad Fort was a royal power centre for the Gaelic kings in 500 to 800 AD. This project argues that the sea and waterways in this area are intrinsic to understanding the archaeology, but are actually very little studied, and hypothesises that their preserved complex of paleochannels and landforms within the marsh suggests that previously the sea or the estuary actually extended close to and perhaps abutted the Donad Fort. So what is currently now a boggy piece of land could have been flooded. So it's how we understand the archaeology in this context. So what it does is it preserves pristine marine lagoon and inlet waterways, which are punctuated by the archaeology. So one of the things that they're doing to study this is they're taking a collaborative and also quite international approach to the geoarchaeology. They're recording paleogeographic and environmental change, and with the aim to understand the sea landscape, the seascape, and how these developments link to archaeological timescales, the impact of environmental change upon human developments. So to do this, they've been taking lots of different cores and doing deposit modelling and geochronology, which is targeted dating of the stratigraphic horizons. And they've recovered information for the last 20,000 years of history in this area. So they've done quite well, I suppose. They've been looking at diatoms, which are very sensitive to changes in salinity and coastal change. So they can look at if it's freshwater or seawater. They've worked with the French Centre of European Research and Education in Environmental Geosciences, and I apologise for my probably very crude interpretation of what that actually is, but my French pronunciation is much worse. And the preliminary results are suggesting that the area of Moyne Moor, so to the south of Donad, was a marine environment up until around 4,700 calibrated BC during the later Mesolithic. Subsequently, these marine clay sediments are overlain by terrestrial and freshwater peats. The peat inception in Moyne appears to begin around the same time as the local dates for the start of the Bronze Age, indicating that in the Neolithic, the southern portion of Kilmartin Glen was actually a fully marine inland lagoon with clusters of islands. This type of information fundamentally alters the landscape and how you view it, and therefore understanding the distribution and development of the archaeology in this area. It also highlights the potential for what you might find around there. So we're looking at domestic, riverine, and sea transport and the associated infrastructure. We could have all of that hidden within this landscape. So more. So this one's the Rising Tides, which is another collaborative project, another one that's looking at landscape change. Now, I don't have their logos up here because there's about 100 of them, but anyway, they've got partners from St Andrews University, Aberdeen University, University of Wales, Trinity St David, Dundee University, us, and Leverhulme. So the aim for this project is to investigate the developing landscape of Orkney through the Holocene, in particular those driven by rising sea levels in that period, and consider the impact of that on the prehistoric communities living in the area. The work was, again, multifaceted. It included very different archaeological techniques, including remote sensing, diver survey, sediment coring, various types of analysis. I mentioned diatoms, dating, together with the consideration of the conventional archaeology. They've also used local oral history and archives to get a better understanding. The sites that they focused on here are Bay of Scale, Bay of Firth, Bay of Ireland, Loch of Stenness, and the island of Sanday. And what the results have shown that relative sea level in Orkney has changed by 20 metres between the period 10,000 BP, so before present, to reach the present levels around 4,000 BP. This change was quite rapid in the earlier millennia, which means that there is a huge potential for a submerged landscape around Orkney, with the possibility of both Mesolithic and Neolithic archaeological sites that we're just not seeing. In practice, I think they found it quite difficult to identify or to ground truth these because of stony substrate, seaweed, visibility, and various other issues. But what the team do feel that they're getting out of this is an approach to human use of submerged landscape and landscape reconstruction. It's slowly being considered worldwide, and Orkney has a massive significant role to play here. So they do believe that the earlier terrestrial archaeology of Orkney clearly needs to be re-evaluated given the diminishing land mass. They've been looking at sites like Skara Brae and the Ness of Brodgar particularly. So at the Ness of Brodgar they're looking at, and you can see the impact on the built heritage because it's built of stone. And what they think is that the way that they're looking at sea level change here can be applied to other bits of Scotland in the island, so looking at Western Isles and also in Shetland. And to stick with Skara Brae for a moment, I wanted to mention some of the work that our digital documentation team have been doing monitoring coastal change at this site. It's defined as a high risk within HES's climate change risk assessment for our properties and care. And this is a document which looks at the risks for coastal heritage from natural hazards, so erosion, ground instability, flooding. And the aim for the monitoring of the project is really to get a better insight into how the coast is changing at this site, not just through coastal erosion, but how deposits are building up and then dumping of material as well. What this is doing is feeding into future management and conservation strategies. So they took the baseline survey, which is down here, in 2010, and what they're doing is they're revisiting the site every 2 years and rescanning. They're using specialist software which can give them the changes down to a millimetre, which is quite fantastic. What they're doing is they're sharing all the results with conservation architects and with partners on Dynamic Coast. I put up here if anybody's interested in having a look, because what they have is the National Coastal Change Assessment, which is aiming to create a shared evidence base to support a more sustainable coastal and terrestrial planning decisions in light of changing climate. So HES is one of the partners of many in there, which include the Scottish Government, includes SEPA, includes the councils as well, and Scottish Natural Heritage. So I wanted to throw that in there. So we're getting a bit more digital, so I thought we'd go on to something a bit different. So I do count, as do many of my colleagues, innovation in digital science is an important part of the facet of archaeological science. Our World Heritage Site coordinator for the frontiers of the Roman Empire was successful in securing funding from Creative Europe to work with partners in Germany and Austria to create an interactive app, it's known as ALAP, for a number of sites on the Roman frontier. This is an app that you can download when you're at home, you can use your Wi-Fi, and then what it'll do is it'll give you a digital tour of the site when you go out there. It contains digital modeling, 3D scan data, augmented reality. You can see here, depending on what site you're along, you can click on it, you can have a look at this. You can manipulate this image to have a look at it. It's a 3D scan of the actual item. You can walk past sites and it will ping and it will tell you. So if you happen to walk past the bathhouse at Bar Hill, which is the one that is up and running, so if you're going to Bar Hill, totally recommend it. And what that one will do is it'll ping if you walk past the bathhouse and give you as much or as little information as you want. So the forts that are being covered in Scotland here are listed here. As I mentioned, Bar Hill is the one that's complete. The rest are hopefully in the next couple of months going to be up there. And I wanted to mention Old Kilpatrick. So I don't know if anybody knows Old Kilpatrick, but there's actually no visible remains on the surface. So what this app is going to do is give you a bit of a guided tour around the town, which is now there. And you will be able to see through augmented reality a few of the finds, where they were found. You'll see the bathhouse and hopefully also see some of the connections with the Clyde as well, so the boats and harbours. Sticking with this same sort of theme, another way that digital science is bringing people face to the face of the past is through gaming. So Go Roman is a quest-based approach to learning. It's targeted at children, but to be honest, it's quite fun and I can completely recommend it. I'm not very good at it, but if you wanted to go online, you can download it and have a go. So you can play the game, you can take a tour of the site, you can be Verecunda, the slave girl getting yelled at by the cook, which is what you're seeing here, or you can be Julius, one of the elite archers. If you have a VR headset, you can put your phone into the VR headset and you can walk around like you were part of it. The children absolutely love it. It made me feel really sick, especially when you're running. If you run through the fort, not a good thing. So I think the teachers are really quite excited about this because they're finding that they're getting the game, they've got good learning outcomes, and children are a bit more engaged with this type of learning than the traditional. To stick with this will probably be familiar to a lot of you who are regulars here. I couldn't resist not mentioning Paints and Pigments of the Past by Dr. Louisa Campbell. She presented, I know, at the anniversary meeting, and for those of you who weren't there, she's using portable XRF and Raman spectrometry to identify potential remains of paint on Roman distance slabs. These non-destructive techniques provide the elemental composition of the paint, and with that you can start to identify colours, shades of colour, and also create palettes for reconstructions. So there's quite a number of problems. I don't know if she concentrated on those, but I'm going to concentrate on those. She'll probably hate me for it, but she had quite a lot of problems when using this technique. So one of these was that most of these are on sandstone, and sandstone has an high iron content. And if you're looking for red paint painted onto sandstone, you're looking for iron oxides that are not relating to the iron in the stone. So it's really quite complicated. There's lots of different ways you can overcome this. You can look at scanning on the bare stone, trying to create a baseline. You can have a look at plotting other types of other elements which you might get, such as sulfur, potassium, calcium, titanium. These are also typical in pigments. You can do that too. If you've got a baseline, you can start to plot everything against the baseline and identify what might or might not be part of the paint. Well, we also have the XRF, and it's an inability to identify organics, and so for compounds, you might need to look at using something like X-ray diffraction instead, especially if you want to infer pigment preparation as well, because looking at whether a pigment's been heated can help you. So lots of different things that you can do with it, lots of different problems. But one of the things I did want to mention here is a collaboration. Her future part of this project is in collaboration with the physics department, and what she's looking at doing is creating a piece of technology that will be specific to archaeology. Now, we tend to borrow most of the techniques that we use from other disciplines. So this is quite a nice one where she's going to be creating her own piece of technology that's specific to archaeological problems. So I'm really excited to see where she goes with that. Now, I promise I am getting there in my whirlwind tour of HES and science. And I wanted to provide you with a bit of an interesting, slightly different thing for us. The Olive Trees by Vincent van Gogh. So my favourite, so I'm quite excited by this, my favourite artist. So I just wanted to use this project to illustrate the versatility and also how frequently PXRF is being utilised, not just in archaeology, but also in art. So the Olive Trees is one of a series of 15 paintings which the artist produced over the summer of 1889. And the National Galleries of Scotland and HES are working together to get an enhanced understanding of the chemical elements present in the paint that was used by the artist. They're using, again, XRF analysis. What it will allow is a comparison with other paintings by Van Gogh undertaken around the same time of the same subject matter, and those that are located around the world, so those in USA, Sweden, Amsterdam, and the Netherlands. In addition to the XRF, the team are also using infrared reflectography, where they're able to see beneath the paint. So that's what you might see on some of these news stories where you have the painting under the painting, that's what they've been doing, and X-radiography. The final results are not in for this, but because it's a permanent collection item within the National Galleries of Scotland, I would keep an eye on their website for the results. And I think because it's been such a fruitful relationship, I think we're looking at working together again in the future. So it might be another dimension for us yet. If we're looking at, I want to move on to a little bit of conservation. So sticking with the theme of digital recording, but move more onto conservation and management, I don't know how many of you are aware of the Hill House, which is Macintosh architectural work, which is located in Helensburgh. It's in the care of the National Trust for Scotland, who restored it to look as it did in 1904. Where you might have heard about it is they're constructing a big box to go around it. Does that ring any bells? Because what they want to do is allow the building to dry out and to enable some conservation work. So our HES conservation team are collaborating with the NTS to provide science and digital research to support the conservation programme. What they've done is they've undertaken laser scanning and infrared imaging and 3D moisture mapping. So what you have here in these are it's the thermal imaging mapped onto the 3D model. So you can look at where there's targets. So you can see here, well, might have a bit of a damp problem there. And you can see in the corners of the rooms, you can also see where the water is getting in. Oh, it doesn't like this at all, does it? Here you've got the blue here, the blue and the green. And so what they're using this for is looking at prioritisation and also more targeted conservation work. So they're continuing to work with them as they build their box. Something quite pretty now, I think. So again, looking at conservation and management, what we're doing is monitoring or helping with the monitoring of the condition of stone sculpture within the St Andrew's Cathedral Museum, and it's been an ongoing project since August 2017. The museum is described as housing an outstandingly important collection of early Christian and medieval carved stones, including the St Andrew's sarcophagus, which is that here, which you can see is the 8th century, it's possibly an 8th century royal tomb. Our conservation scientists were called in due to extensive salt efflorescence, which I hope you can see in here, which is actually really damaging for all of the sculpture in there. So the task for our scientists was to analyse the salts, determine the ideal environmental conditions of which to control salts, and then to ensure long-term stability of the collection and of the building. So prior to this, there'd been expensive environmental modelling, so they knew that there wasn't big changes in temperature and not big changes in humidity. And they took 122 samples from across the walls in 3 rooms of the museum, including variations in height, aspect, proximity to heat sources, ventilation, doorways, and substrate. To their horror, and I quote them, horror, they discovered a very complex range of salts here. So what their problem is you can see that there's sculpture on the wall, so you've got direct contact between the salts, and then you also have salts dripping down onto the sculpture that's on the ground, so and it's all significantly damaging. These 4 here, they are actually identified out of cement. So what they're doing is these are leaching from the cement inside the building and creating the damage. So the work is ongoing. They're trying to identify, have a look at the cement analysis during forthcoming roof works. They want to look at the salt growth, whether it's active, use time-lapse cameras, and ongoing moisture monitoring and thermal imaging, because they want to put in a new heating system, and they can't do that until they can figure out what environmental conditions will work. Now, my last one, I promise, absolute last one. Fossil Grove in Glasgow. So this is somewhere that I didn't know about, but I assume from those noises that people do here know about it. It's located in Victoria Park in Glasgow. It's a site of special scientific interest because of the fossilised remains of 325 million-year-old Carboniferous lycopod trees and their root systems, which are uniquely preserved in their growth positions. It was discovered in 1887, and the area was encapsulated, you can see, so with laser scan here, and it opened as a visitor attraction and is considered the world's earliest example of geoconservation. The age and lack of regular maintenance of the building, however, has taken its toll, and the condition of the fossils is now of concern, and as a result of salt growth and excessive condensation. So Historic Environment Scotland have been assisting all the bodies responsible for this since late 2016. So I'm going to hopefully show you. You should be able to get an idea of the issues, the waters, and also in the bottom here you have the salts that are being left behind. So again, more of these damaging salts. So what they're doing is they want to advise on how to stop current decay, how to stabilise the conditions for long-term preservation of the fossils, while developing recommendations for a long-term management strategy. They're using 3D modelling, building pathology and stone conservation. They're creating a risk map of the surface as a practical management tool. They're using time-lapse photography here, so they can look at how the environmental conditions, external environmental conditions, are impacting. So you can see in here, you could see the water coming in, filling up and draining away. And they're also using identification of the potential sources and transport pathways of the salts using X-ray diffraction and X-ray fluorescence. Now, I couldn't end without looking to the future, because I did promise that we'd do that. And I think that our PhD studentships are definitely part of that. Hopefully the tour of projects has given you some idea of how wide-ranging archaeological science can be and its benefit to helping us understand more about our past. And what I hope it has also illustrated is that in Scotland we have the people, the expertise, the innovative thinking, the technology, and also our strategic overview to ensure that science is robustly applied to all projects. And here we have our archaeological science PhDs. They range from isotopic study, looking at diet, they're looking at refining chronology of the Neolithic through archaeomagnetic dating. The chronologies will be further defined within the 3 PhD students from Zurich here, and we'll also be starting to look at connections of prehistoric people between mainland Scotland and the Western Isles as well. We have a couple of other PhDs that are ongoing, which are looking specifically at management and conservation of sites. So whether that be negative archaeology, such as evidence for Pictish settlement sites, through to the impacts of changing climatic conditions on stone. And I'm sure you'll be hearing a lot more from the researchers in years to come. Eh, Sophie? Yes. She didn't just pull a face. So I think what we can say really is that the future in archaeological science is bright. We have a solid foundation with SCARF and the science panels. We have burgeoning regional research frameworks and Scotland's archaeology strategy. Archaeological science, I think we're going to find, is going to become much more standard. And nowadays, archaeologists will take radiocarbon dates. They're starting to look at isotopes, and I think that we're going to do the same. And as they become more, as we become much more standard, and with advances in technology, we'll see these analyses become cheaper and more accessible. We're going to find them faster. We're going to find that they're going to fit quite nicely into the timescales of projects. We're also going to find that they're portable. We talked about XRF, and it's a smaller version of a big one that you find in a lab. And I think that the technology for making things portable and better refining it is definitely going to take us somewhere, especially when study of objects in situ is so important. We're going to find it's non-destructive, so more and more analyses are looking for non-destructive ways for analysing material. So if we're looking to better understand some of the most significant finds that are held within museums, we probably don't want to crush them up into a million bits in order to find out what they're made of. as you've heard and as you've seen, there's advances in digital science, so scanning and how we present data, how we create data, how we disseminate data, and I think that that's going to be really important. I think most of what we do is digital and accessible. So again, we'll have the results digital, we'll have them online and free to access for all. So thank you for listening. I know I've gone over time and apologies for that. And I also want to say a massive thank you to all of these people who produced information for me today. So thank you again.